In this video, we will use the pumping lemma to prove the non-context freeness of the following example languages. Follow along to get a flavor of how to go about proving such theorems. The first one is a kind of prototype non-context free language, a power n, b power n, c power n. We will show that this is not context free by applying the contrapositive of the pumping lemma. Firstly, we pick a string in this language that is at least as long as the pumping length. There are more obvious and less obvious choices of strings here, and AP, BP, CP is of the former kind. Remember that we have to show either one of the three conditions to be true for all u, v, x, y, and z. Conditions b and c can always be shown true for a subset of values of u, v, x, y, and z. So the real task is to prove for the remaining set of values where conditions b and c are false and hence condition a must be true. That is, we have to show that for all u, v, x, y, z where vy is non-empty and vxy is at most the pumping length, there exists such a pumped variant of the string that is not in the language. We know that the substring vxy is at most the pumping length. So it consists entirely of A's, or a mix of A's and B's, or entirely of B's, or a mix of B's and C's, or entirely of C's. These five possibilities can be grouped into two cases. Case 1, when both V and Y contain only one type of alphabet symbol, either only A's, or B's, or C's. Then pumping up once will result in a string with more symbols of one kind, and that is not in the language. And case 2, when V or Y contain two types of symbols, then pumping up once will result in a string that has incorrect ordering of A's, B's, and C's. Both cases result in a contradiction, and since one of these cases must occur, we have successfully shown that pumping our chosen string twice results in it not being in the language for all valid divisions of u, v, x, y, and z. For the second example, the choice of a string is a little less obvious than last time, but we will pick the same string AP, BP, CP. As before, there are the same two cases to consider for the substrings v and y. Case 1, when both v and y contain only one type of alphabet symbol, either only A's or B's or C's. Then, when they contain either all A's or all B's, pumping up the substrings once will move the string out of the language, or else, when they contain just C's, then pumping down the substrings once will move the string out of the language. Make sure you understand why that is before proceeding. And case 2 is when V or Y contain two types of symbols, in which case pumping up once will result in a string that has incorrect ordering of A's, B's, and C's. Both cases result in a contradiction, so once again the language has been shown to not be context-free. For the third and final example, the choice of string is perhaps even less obvious than last time. Which string would you pick intuitively? We'll go with the string 0p, 1p, 0p, 1p. We know that the substring vxy is at most the pumping length, so it consists entirely of zeros, or a mix of zeros and ones, or entirely of ones, or a mix of ones and zeros, or entirely of zeros, or a mix of zeros and ones, or entirely of ones. These 7 possibilities just described can be grouped into two cases which unfold into different subcases. Case 1, when both V and Y contain only one type of alphabet symbol, either zeros or ones, then pumping up V and Y once will move the string out of the language. And case 2, when V or Y contain two types of symbols, then pumping up once will move the string out of the language as well. You should make sure for your own understanding why it works out as it does for each of the three subcases in case 2. Pay special attention to the middle case when the window spans the middle of the string. Once again, both cases result in a contradiction, so the language has been shown to be non-context free.